couple other things that we can do. So first, we're looking at numerical data this time. The following data represent the number of available cars in a household based on a random sample of 50 households. Construct a frequency and relative frequency distribution. So we did talk on Friday that you can do these by hand. You're welcome to type them on Google Sheets, whatever works well for you. Since I'm going to make both frequency and relative frequency, I'll go ahead and just do it by hand. It's not going to take too long here. So this information is telling me the number of cars. And we will need the frequency and the relative frequencies. Okay, so kind of looking at my data, what options do I need for my number of cars? And we need a 0.
Yes. I looked at 0, did not read 0.
Okay. What does it mean when I ask you for the frequency?
How many times?
How many times? Okay, so how many zeros are there? All right, how many times do we get a 1?
13.
Let's go and count our 2s.
They're so close together.
You guys get 22 2s. 3s. 4s. So frequency distribution just means make a table, tell me the outcomes and how many times it happened. How do we do relative frequency?
Animal and divide by the number.
And a good check, make sure we didn't miss any. If you add all these numbers up, what do we get? 50. And it told me in the problem that I had 50 households. So that would be a good way to make sure I didn't miss one. So we just take each of these divided by 50. So 4 over 50 or 0.08. You don't have to write the fraction. I'm just showing you what I'm doing. 13 over 50 is 22 over 50. 7 over 50. 3 over 50.
0.06.
And 1 over 50. And what should these relative frequencies add up to? 100%. So add them all up, you should get 1. It's possible that it may not be exactly 1. Remember, we did a relative frequency table Friday, and our relative frequencies were like repeating decimals that went on forever. So if you were going to do that, you have to round a little bit. If there's rounding, it may not be exactly 1, but it should be very, very close, unless you made a mistake along the way. All right, so this was stuff that we did before. Are we okay with all that? So we might ask you to make what's called a histogram. We were doing things on Google Sheets. Google Sheets will not make a true histogram for us. A histogram is very similar to a bar graph, and Google Sheets does the bar graph. But in a histogram, we have our data broken into classes, and when you draw it, all the rectangles have to be touching. Why is it's giving me a definition of a histogram. The computer is talking to me. That's a little.
That's your phone.
Is it my phone? Oh, It is. Why is my phone telling me the definition
Did you
of
say hey Google or something?
That's weird.
I can't remember. We're gonna listen back to the tape on what you said. To
I
trigger
know. What did I say to trigger that? It's a little bit true.
Okay, let's get back
Okay, so we would have to do this by hand if we were going to make a true one. I'm going to kind of show you what it would look like. We can also make them on our graphing calculator, but most often if I want a histogram, I'm probably going to give you one and you're going to be reading it, not necessarily
We
creating one.
didn't finish the definition of histogram. We got what is like the bars? You said they were touching.
Yeah, so it's like a bar graph, but they're touching. And then a lot of times if you have like continuous data, instead of just saying it's 1, 2, 3, we might have classes. So we'll make one bar for everything between 0 and 5, and another for everything from 6 to 10. So if I were going to make a histogram of this, so going back, this is example 2. So this is what we just made, right? If I were going to create the histogram here, we're going to draw one by hand. You can do it on whatever slide. Don't script it. We actually need to put, we don't want this to be 0 right here. So we're actually going to make our 0 here because that's one of the bars I have to create. So my bars are all my number of cars in this case. And if you're going to make a graph, you need to label it. So this is the number of cars. And then my y-axis will be our frequency. If we look, our frequencies were anywhere from 1 to 22. So you could count by ones. I'm going to count by twos. All right. And so then you essentially make a bar graph, but the label is kind of in the center of your bar. So 0 was 4, so you would make a rectangle that's centered around 0 with a height of 4. And 1 showed up 13 times. So these rectangles the bars are all connected. So we draw it to a height of 13, centered around the 1, but they're touching. 2 is 22. 3 was 7. 3 and 5 was 8. Okay, so it's just a little bit different in that those bars touch and that your label is at the center of each rectangle, not on the edge. Any questions about that histogram? Okay. So next we talk about what if we have continuous data? This was discrete, countable, 1, 2, 3, 4, 5. But if I were measuring how long it took you to do something, we know that's continuous data. So I don't want to list out every single response because then I would have way too many bars. It just wouldn't be useful. So sometimes we use what are called classes. Those are just different categories that we use to group our data. Typically we do this if we have continuous data or if we have discrete data but a large number of it. We might try to group things together when we're creating our histogram just to make it a little bit easier. So I'm going to look at an example and we are going to make a frequency and relative frequency distribution here. Now, if I look at this, okay, do you see a lot of repeated numbers? No. Is it going to be, this is the amount of time between eruptions of Old Faithful. Is it useful for me to list 45 different numbers, all with a frequency of 1? No. So this is a case where we might want to do it differently by using classes. So let me show you how that works. We're going to start out, we're going to have our time. I can't trust your time. Let's kind of get an idea of how spread out this data is. What is our smallest number? 672 is our smallest. What's our biggest number? 730.
Middle.
Okay. So I have to do something between 672 and 738. Let's say, I'm going to start this one. I'll go 670 to, let's just count up by tens. So I don't want to say this is 670 to 680 and then the next one starts at 680 because then you wouldn't know where to put 680. So the first one has to stop at 679. Okay, next one will be 680 to 689. 690. 699, 7 to 709, 710, 719, 720 to 729, and 730 to 739. These have what are called a class width of 10. We might want to kind of jot this down. I'll go back to that slide in just a second. But if I say class width, that's the distance from the start of one class to the start of the next. Okay, so not from the start to the end of that one class, but from the starting of one to the starting of the next. So between 670 and 680, that's 10. So these have a class width of 10. If I asked for a class width of 5, we would have more things to list there. The bigger your class width usually, then the smaller number of groups you'll have. Let's kind of divvy this up. Alright, why don't you guys count, so you three count how many are between 670 and 679, 680 to 89, 90 to 99, 709, what am I on? 700 to 709, you two do 710 to 719, and I'll count the last two. How many between 670 and 679?
2.
Okay. 680 to 89.
0.
90 to 99. 700 to 709. 710 to 719. Okay, and then the last one, 720 to 729, there were 11. And 730 to 739, there were 7. Alright, so then how do we get our relative frequencies?
Add them all, make sure they add right.
Yeah, make sure we didn't miss anything. So if you add them up, do we get 45?
Yep.
So then we take each frequency divided by 45. Now this one doesn't come out perfectly. So I'm just going to give 3 to 4 decimal places is pretty good. Round as needed. So I'm dividing by 45.
I wish decimal was too much.
Mine actually still added up to 1.
I don't, why I did.
Oh.
I got that more on 90.
Yeah. So the more decimal places you have, the more accurate you are. If I had mine up, it still does magically still add to 1, but it's not. Wouldn't be surprising if you got 0.99 or 1.01 because we do have some rounding error there. All right. Is this okay? So if I wanted a frequency distribution of that, we can do it by hand. We can also do it from the graphing calculator, which is not something I will have you do a lot, but we can. So I wanted to show you guys how to do that. So everyone needs a graphing calculator. And the very first thing you are going to do is we are going to put the original data into our calculator. Every original number, yep. So,
With commas?
no. We are going to go to Stat. Okay. Number 1 is Edit. Now, first thing, there are lists here. You do not want to use delete to take a number out of a list, because then that actually deletes the whole list title, and it's kind of annoying to try to get it back. So what you do is, if you go up onto the title, if you hit clear, enter, it'll wipe out everything in there. So I'm going to do that for both of mine. Did everybody get to the screen? Have your lists cleared out?
Can we have just,
So it should say L1 and it's all blank.
can we have just been stat 4, stat clear list?
Okay, so now I want you to enter those original 45 data points into your list. So you just hit 1, hit enter, go to the next. So once you have it entered, if you hit second, the y equals, this takes us into our plot, all the different things it can plot. So second y equals, we should all be looking at this screen. So we're going to go into the first one, just hit enter. I want to turn it on, so highlight on and push enter. And if you want to just do this with the list that you have in the first one, that's fine. You'll get the process, it'll just look different than ours. Second. first you have to turn it on. And then it has the type. These are all the different graphs this will give us. We want the first one. Looks like a histogram. And so it only gives you the option, pick one list that you want to do. So we have ours on L1. We put all of our data in there. So then we just go through here, hit enter.
We don't want to do a frequency of 10.
So depending on the information, we might want frequencies of 1. We can do class width. It might be, I'm going to keep my frequency as 1, and then I'm going to show you in a little bit how we can fix the width. So if I just go through here and try to look at my graph right now, it's not going to show me anything. Okay, we have to tell our calculator what we want to look at. So I'm going to go into window now. All right, is everyone with me? So we're in window. Okay, you notice our x's are set to be between -10 and 10, but look at the data we put in. Do we want to be between -10 and 10? No. Our smallest would be 670, and we ended our graph at 739. All right, our scale is like our class width. That's going to be our 10. All right, the y's, that's like going to be our frequency. So 0 is our lowest. Our highest is 11. I'll just go 0 to 15 and see what it looks like. And then if we go zoom, number 9, that will zoom to where our data is. So zoom, and number 9 it says zoom stat. So we're going to go, whoops.
This is so cool.
And it gives us our history. The highest bars went to 7. And the scale is like your plus one, so that was like 10. Our y's were 0. You most likely mistyped a point in there. Yeah. So that's okay for I can show you. Yeah, we'll do this later, but you would put it all in one list and find your data from there. Okay. Obviously this is kind of time consuming. There are benefits to it, like if we are checking our data to see if we have a lot of really high values, a lot of really low values, some different things, but not something we're going to spend a ton of time on. I do want to, let's see. Okay. The other option for how we could graph our data is to make what's called a stem and leaf plot. And this used to always be taught, but then last year they said they'd never heard it before. This used to be like a middle school thing. Have you guys ever done a stem and leaf?
I don't know what the words are saying.
Okay.
Maybe.
So maybe, but maybe not. Alright. You do them? Alright, so if we make what's called a stem and leaf, you basically organize your data. So if I had points like 12, 17, 19, 21, 25, 25, 30. Okay. You can create that. Your stem would be your leftmost digit. So my stems here would be 1, 2, 3. Your leaf are your rightmost digits. So we had a 12, so 1, 2. We also had a 17, so 1, and then we just put the 7. 19, so 1, 9. You don't have to put commas between them, you just list them by each other. They do need to be in order, so if I hadn't given you the numbers in order, you would arrange them. You don't want 9, 2, 7, because So with a stem of 2, we would have a 1, and I had 25 twice, so 1, 5, 5. 30 is 3, 0. So that's a stem and leaf. The benefit of this over like what we were doing before, when you look back at this, okay, I can tell there were 7 times between 690 and 699, but do I know what those times actually were? No, I've lost those original numbers. So your stem and leaf might be more beneficial if you need to know the original numbers later on. You can keep them. So I did an example for you. I'm not going to go through the whole thing, but this is basically each state and the unemployment rate. So you'll notice these all have a decimal, but they have a leftmost digit. They have a rightmost digit. Okay, so you can use a stem and leaf even with that decimal data, and it would look something like this. Now you notice this one did split. I have a stem of 3 twice. Sometimes you see that if you have a lot of points. So they did one stem for everything from 3.0 to 3.4. The next one 3.5 to 3.9. You don't have to. You could put all those on the same stem of 3. But just so if you see data like that, trying to make it a little clear what you're looking at. So they usually only do that if you have a lot of points that you're trying to look at.
How would we do it for the one with the geyser?
So you would go ahead and use the 100 spot as your stem, and your leaf you would put the next 2 digits, but then just leave a nice space before you put the ones beside it.
I've never done this in my life.
You haven't ever done stem and leaf? Okay.
I didn't. Did the people over there do it?
A couple people had seen it, but not many. The reason we look at all of these different representations is to try to decide the shape of our data, which will be really important going on. One final one we actually did the first day of school. It's a dot plot. You guys remember when I had you roll the dice and we put dots to show? So dot plot, you basically just have your X and Y axis and you put a dot to show your height. So that's the final one. So I just want to jump down to the shape, and that'll be the last thing we talk about today. This slide is important. So you might put a little
That's not
slide.
Hmm?
You don't have the slide? Yeah. Okay, so I just took the example. So you might need to jot this down in your notes or something somewhere. You are going to hear me use these terms a lot. Uniform is basically just a flat line. Everything has the same chance, the same frequency. So it might be that I roll the dice 200 times and I got each number the same number of times. Okay, so uniform, everything's the same. Why don't I let you write and then I'll talk.
What I like the shorthand.
You can shorthand, that's fine.
With your shorthand, it's like
Okay.
yeah, any class.
Uniform, they're all the same. Bell-shaped is going to be what we want most often. That's good data is bell-shaped, which is basically you have the most data grouped in the center and it tapers off as you go to each side. And so if we're kind of looking, this is uniform, the first histogram, straight across, everything's the same. Second histogram is more bell-shaped. Starts out low, it increases, and then drops back down. Skewed left and right, that's usually a sign that something's wrong with our data. So if it's skewed right, you have more high points, and then it trails off, and so it extends really far to the right. You have a lot of high points on the left, and then the right tail goes on forever. Skewed left, you have a lot of low values with a low frequency, and then you hit your peak. So if it extends on to the left, that's skewed left. If it extends on to the right, that's skewed right. staring at you because it really looked like you were eating Carmex for a second. It looked like a Carmex tube, and then you kept sucking on it. It is disgusting. What is wrong with you? Okay, so here's our histogram for Old Faithful eruptions. How would you describe that shape? Skewed left. We have some low points down here, it's rising, and then it drops off. So you have more to the left. So this is skewed left. Okay. I know this, I'm taking a little bit longer to get through the notes. It'll get faster when we don't have quite so much data that we're putting. So here's my trade-off. I taught Sept 2.2 today. Tomorrow I'm going to do 2.3. Then Thursday, let's see, today's Tuesday, right? So Thursday I'm going to give you a work day for both assignments. Okay, so I won't actually collect anything that Thursday, but that was because I thought today was Monday this morning, I think. So Friday, I'll collect both assignments. So you have a work day coming. I would still probably start it if I were you. I wouldn't wait until the last minute to try to get everything done. But there will be time to work in